Hey Athena, my name's Laura, and I'm here to see if I can answer your projectile motion question involving a rocket. I think that you didn't get a lot of answers because we have to make some assumptions in order to solve this that aren't actually said in your problem and kind of should have been. So we need to make the assumption that we're on Earth, because that would mean that our gravitational force was 9.8 meters per second squared. I said force, I meant acceleration, 9.8 meters per second squared. And we also need to assume that this rocket's going straight up and straight down. Otherwise, we would only be finding the y component of a more complicated velocity if this was getting shot at an angle. But if we make the assumption that we are only worried about going up and down, we can solve this. And this is how we solve it. We actually split this up into two separate parts. And whenever you see a problem like this with something going up and then landing, think, I'm going to use this important fact. The amount of time it takes for me to fly up in the air when I'm being accelerated by gravity, it's going to equal the amount of time it takes for me to fall down from having been in the air. We're also assuming that all the energy of speed was right with that initial velocity, that we don't have an ongoing poof poof of the engine helping this thing fly. It's just going up, falling down, all under the acceleration from gravity. Why is that important? Well, that means that the change in time for this first half of the flight, when the rocket is taking off, that little triangle is supposed to be a rocket, is going to equal to the amount of time it spent falling. So why is that important? Well, we were told 6.5 seconds, which means half of that was spent going up, or 3.25 seconds, and half of that was falling down. So let's go ahead and note that on our little drawing. Little drawings help so much in physics. Always do little drawings to help you organize your thoughts. Now, here's some other really important things. If we try and solve for the distance, the height that it goes, using this information to try and find out how it goes going up, it's actually not going to work, because we'll end up not having enough known things. We need to instead look at the second half of that flight. Why? Because when we fall down at that turnaround point, our initial velocity will be 0. So let's think about us figuring out how far we're going to fall, because that, of course, is going to equal to how far we came up in the first place. And so that's going to be the x that we use to find in our equation to find our height overall. So our distance is going to equal to the position of where we fell from. And right now we're going to call that our initial starting point as a 0. So that's going to be our x initial is going to be 0 up here. So we're going to be finding how far below that point we fell. All right, so we're going to equal to that x initial plus our velocity initial in the downward direction. Again, since we're right at the top of the height, that's also going to be 0. And 1/2, our acceleration is gravity, so I'm going to put in a g instead of that a, times time squared. And now, remember, by looking at this in a particular way, we were able to make a bunch of things be 0 and get mu from this. So x naught, we said that was going to be 0. Boom, it goes away, because we set it up so that our height is actually at 0. Then at the turnaround point, our velocity is 0. So since 0 times time would be 0, this part goes away. And we're left with all we need to figure out how big this fall is this 1/2 gravity times time squared. So our height is going to be 1/2 times 9.8 meters per second squared times the time of flight, 3.25. And that will be squared, second squared. So we plug this into a calculator. We get out 51.756 as our total distance covered. All right, so let's go ahead and round that off to sort of the same level of accuracy as our units for acceleration were given in, 51.8. However, if I do any calculations with this, calculating other things using this distance, I will use more of the numbers past that decimal place to get a more accurate answer, less rounding errors. So don't use your final rounded answer. Use all the gobbledygook that you've got in your initial calculation. So there is our part A. The height that we reached is 51.8 meters. Now we need to find the initial velocity. All right, so as we go up, so we come down. Our velocity initial is going to be the exact same thing as our velocity final at the end. And since we know the distance we covered, we can use that to find it, but that'd be a more complicated expression. Instead, I'm just going to use the fact that we know how long we were in the air, and we know that we hit 0 at the top of the arc of our flight. So the velocity is going to equal to our initial velocity plus our acceleration from gravity, which I'm writing as g times time. So again, if I'm using the second sort of moment where we're falling from the top, our initial velocity, as we're falling from the top, that was 0, plus our acceleration from gravity, 9.8 meters per second squared, times, in this case, it's just time, not time squared, so don't accidentally square it when you shouldn't. And again, our time is that half time of just the fall. And that will give us our velocity final. All right, our velocity back down. Now remember, our velocity final and our velocity initial are going to be the same in opposite directions. That's the only difference. So if I want it to be the final velocity, I need to put a negative sign on this gravity to show that it's pulling down. If I want it to be initial velocity, I just leave that off. Again, they're going to be equal and opposite. So since we're thinking about second half, I will put this negative sign in and go ahead and pull it through. So 9.8 times 3.25 should give us our final velocity falling downwards of 31.85 meters per second. And since it's going down, that negative sign goes with it. And our V initial going up is exactly the same thing, but in the positive direction and also meters per second. Let's see, since we were rounding off at 9.8 for our initial acceleration, let's go ahead and round off correctly. So V final is negative 31.8. Rounded would be 9. Don't forget your units. And V initial would be 31.9 meters per second. So let's see. We need to make sure that we label this with the C so that we know that this is C and that this is part B. And let's just take a moment and erase this B out of here so that it's clear. All right, those are all the parts for answering your question. I hope this helped, and I hope you have a great rest of the day. Bye for now.